Welcome dear students for the GATE coaching class on civil engineering. I am Ms.SARANYASRI, Assistant Professor in the Department of Civil Engineering in SA Engineering College. Let me first brief to you the GATE topics in civil engineering. So there are three major subdivisions: general aptitude, engineering mathematics, and our core engineering discipline, civil. So for civil engineering, we'll be accounting up to 72%, and for engineering mathematics, it is 13% weightage, and in general aptitude, it is 15% weightage. Now, in general aptitude, even though if it is 15%, the number of questions that we are going to answer is 10. Similarly, for engineering mathematics, the number of questions is 10. And for our civil engineering subject, the number of questions that we are going to answer is 45. Totally, we are going to answer 65 questions, and the mark will be 100. In structural engineering discipline, the total percentage or weightage of our syllabus is 9%. Now in structural engineering discipline, there it is 9%. There are other branches like geotechnical engineering, soil mechanics, it is 6%, water resource 8%, environmental engineering 8%, transportation engineering 9%, geomatics and surveying it is 6%, engineering mathematics as we have already mentioned 13%, aptitude 15%, and construction management 6%. Now the topic that I am going to cover is from structural engineering discipline under the subdivision engineering mechanics. What is engineering mechanics? It is the study of objects which are at rest and at motion. So when we are going to study with objects that are at rest, then it is called statics. If you are going to study about objects which are at motion, it is called dynamics. Now our topic of today's discussion is center of mass. With no further delay, we can move on to the topic, center of mass. Center of mass is nothing but the point where the whole mass of the body is supposed to be concentrated. When you hold a piece of book, you can exactly balance it at the centroid. It's because the distribution of mass is uniform at the center. In case of other objects, irregular objects, the centroid and the center of mass will not coincide. For uniform objects like a circle or a cylinder or a cube or a cuboid, the center of mass will be at the centroid. And center of gravity, what is the difference between center of mass and center of gravity? The difference between the two is, here in center of mass, we will be concentrating about the mass of the object, and in center of gravity we'll be talking about the weight of an object. Mass and weight, how are they related? Mass into acceleration. When you consider the Earth's gravitational force into account, then it becomes center of gravity. Now we can move on to a practice problem, the first problem of the session. There are 2 point masses. One mass is of weight 3 kg, the other mass is of 5 kg. They are at distance of 4 meter and 8 meter from the origin. So this is our x-axis and the vertical axis is y-axis. For this 3 kg mass, it is at a distance of 4 meter from the origin. And the 5 kg mass M2 is at a distance of 8 meter from the origin. Now for this we are going to locate the center of mass. The position of center of mass, the formula for it is m1x1 plus m2x2 divided by m1 plus m2. So m1, what is m1? m1 is the mass of the first object. What is x1? The distance of the first object from the axis. So here the first mass is m1 is 3 kg. The distance from the x-axis is x1 is 4 meter. The mass m2, the mass value is 5 kg, and the distance from the axis x2 is 8 meter. And we are substituting that in the equation, m1x1 plus m2x2 divided by m1 plus m2, you will get the position x cm. That means the position of center of mass is equal to 6.5 meter from the origin on the x-axis. So here it is 4 meter, this is 8 meter. In some way midline between this x, that is for the 3 kg and 5 kg, after the 3 kg mass it is at a distance of 2.5, 2.5, and for this 5 kg mass it is at a distance of 1.5. So this is the position of the center of mass for the first condition from the origin. So for the second condition, now you are going to locate the center of mass from this 3 kg mass. So instead of considering it from the origin, we are going to consider it from this 3 kg mass. If you are going to consider it from the 3 kg mass, the x1 position for this first mass will be equal to 0. m1 value is the same. m2 value is 5, but the distance here is 8 minus 4. This will be 4 meter. So x2 value will be 4. Now you substitute it here, 3, the mass of the first object. There is no centroidal distance since we have shifted the origin from the 0 to 3 kg's position. So the x1 value is 0, m2 value is 5 and x2 value is 4. You substitute, you are getting it as 2.5. Now here when you go to this equation, you can find it is at a distance of 2.5 from this position. So for both the cases, even if when you are calculating the position of the center of mass from the origin, it was midway between 3 and 5 kg. Now also the position of center of mass is midway between 3 and 5 kg. In the first condition it was 6.5 meter, that is 2.5 meter from the 3 kg mass and 1.5 meter from the 5 kg mass. Here in this second condition, it is 2.5 meter from the 3 kg mass and 1.5 meter from the 5 kg mass. So you can understand that the center of mass, it is located very close to the larger mass. This is our inference. Now we are moving on to our next problem. This is like in the form of a derivation. Now there is a uniform disc. Their disc radius is capital R. There is a small disc of radius r by 2, and you are cutting the small radius disc and removing it off, and you are going to find out the center of mass for the remaining portion. So let us go for this problem here. Here in this condition, when you are moving here, the bigger mass, the mass of this bigger sphere will be capital M, and the radius of the bigger sphere is capital R. You are cutting the portion which is r by 2. You are cutting this portion from this bigger sphere, and you are going to calculate the center of mass for this portion. Okay. Now, how will you calculate using the principle of moments? M minus M into X is equal to M into R by 2. So, mass of this object is the total mass minus the remaining cut portion. And here, it is the mass of the small disk into the remaining portion R by 2. What is surface mass density? Here, M is equal to surface mass density into surface area. M is equal to sigma into pi r by 2 the whole square. So what is M here? M is the mass of the bigger sphere. The area of the bigger sphere is pi r square, and the area of the smaller sphere is pi r by 2 the whole square, since for the smaller sphere the radius is r by 2. Now r square, pi gets cancelled, you are getting M by 4. That is, the mass of the smaller disk is 4 times the mass, 1 by 4 times the mass of the bigger disk. So now you are going to calculate the position of the center of mass for this remaining uncut portion. When you are going to calculate for this remaining uncut portion, x is equal to what? X is equal to, we are moving on to the previous slide, where x is equal to m divided by capital M minus small m into r by 2. But what have you inferred here? M is nothing but capital M by 4. So you substitute capital M by 4 in this step. Wherever you get small m, you substitute as capital M by 4. You are getting it as M by 4 minus M by 4 divided by 3M by 4 into R by 2. So the position of center of mass for the remaining uncut portion is R by 6 from the left of the disc. We can move on to the next problem. You are going to locate the center of mass for this uniform rod. We are going to calculate for this uniform rod of mass M and length L, what is the position of the center of mass. Now this rod is of length L, the distance is x. You are going to consider only for the smaller portion. How will you consider it for a smaller portion? If I consider it for a smaller portion and integrate for the entire limit, I will be getting for the entire length of the rod. So this is a uniform rod, the mass is m, the length is l, okay. You are going to locate the center of mass for this rod. So how will you write the distribution? xcm. What is xcm? Position of center of mass is equal to integral x into dm divided by integral dm. When you integrate the mass fully, the small section, you will get capital M, that is the mass of the entire rod. X into x dm. dm value is m by l into dx. For this small portion, infinitely small portion, what is the dm value? It is the mass of the rod divided by the length of the rod into dx. When I apply the limits, integrate and apply the limits, I am getting it as 1 by l. When you integrate x dx, you are getting it as x square by 2. Apply the limits, half 1 by l square by 2. l gets cancelled against each other, it is l by 2. l by 2 is the geometric center of the rod, and it is the point where the whole mass of the rod is supposed to be concentrated. Am I clear, students? Shall we move to the last problem of the session? This is a very interesting problem. A man of mass 50 kg is standing at one end of the boat, and the mass of the boat is 300 kg. It is floating on a still water. The man who is on the boat is walking to the other end of the boat, and this movement is observed by a stationary observer on the land. And according to him, he finds the velocity of the person walking on the boat to be 2 meters per second. What will be the velocity of the boat with respect to the stationary observer on land and also with respect to the man who is walking on the boat? Now the formula for this is m1v1 plus m2v2 by m1 plus m2 is equal to 0. This is the formula here. What is m1? m1 is the mass of the person who is walking on the boat. What is the mass? 50 kg. What is the mass of the boat? Mass of the boat is 300 kg. What is the velocity of the person? Do we know that? Yes. According to the stationary observer who is on the land, the velocity of the person who is traveling on the boat is traveling with a velocity of 2 meters per second. So v1 is given. You are going to calculate v2. I told you, right? m1 v1 plus m2 v2 divided by m1 plus m2, and cross multiplying m1 plus m2 will be equal to 0, and you are going to calculate v2. m1 v1 is equal to minus m2 v2. v2 is equal to minus m1 by m2 into v1. What is m1? Mass of the person, that is 50. Mass of the boat, it is 300 into velocity of the person. According to the observer, it is 2. You are getting the velocity as minus 0.33 meter per second. Understand, the person is traveling on the boat. The person who is traveling or is on the land is watching this motion. According to him, the velocity is in the negative direction. That means in the opposite direction the person is traveling. Okay. Next condition, you are going to determine the velocity of the boat with respect to the walking man. Who is the walking man? The person who is traveling on the boat. What is the relative velocity? Already we know that the velocity of the man is 2 meters per second and the velocity of the boat is minus 0.33 in the previous step. So V21, the relative position of the relative velocity is equal to the velocity of the boat minus the velocity of the person. So velocity of the boat is minus 0.33, the velocity of the person is minus 2. Same sign, add and put the same sign. Then we are finding it out, the velocity, the relative velocity of the boat is also in the negative sign. That means both the person who is traveling on the boat and the boat is traveling in the opposite direction in which the stationary observer is watching this motion. Okay. So the basic problems on center of mass has been discussed in today's class. In the next section, we will be looking on to the harder difficult sums in the next class. I hope you would have understood center of mass concept, students. Thank you.